Alright, so in this problem, I have x to the power of 6 minus x to the power of 3 is equal to 2. So I'm going to first start by subtracting 2 on both sides. So now I have x to the power of 6 minus x to the power of 3 minus 2 is equal to 0. Now I'm going to rewrite x to the power of 6 as x to the power of 3 squared. Now I have this minus x to the power of 3 minus 2 is equal to 0. Now I'm going to let x to the power of 3 equal to the variable y. So now if I substitute in x to the power of 3 for y, y for x to the power of 3, I get y squared minus y minus 2 is equal to 0. So now I'm going to factor this by rewriting this as y squared minus 2y plus y minus 2 is equal to 0. Now I'm going to factor by grouping, so I have y times y minus 2 plus 1 times y minus 2 is equal to 0. So now if I factor out y minus 2, I get y minus 2 times y plus 1 is equal to 0. So this gives me two equations. Y minus 2 is equal to 0 and y plus 1 is equal to 0. For y minus 2 equals 0, y equals 2, and for y plus 1 equals 0, y equals negative 1. Now remember how we let x to the power of 3 equal y. So now I have x to the power of 3 is equal to 2, and x to the power of 3 is equal to negative 1. So for x to the power of 3 equals 2, I can simply take the cube root on both sides. So now I have x is equal to the cube root of 2. And for x to the power of 3 equals negative 1, again, I'm going to take the cube root on both sides. So I get x is equal to the cube root of negative 1. And the cube root of negative 1 is simply negative 1. So I have x is equal to negative 1. So these are my two solutions to this problem. Alright, so in this problem, I have 2 to the power of 3x plus 2 to the power of x is equal to 10. So to solve this, first off, if I have something in the form a to the power of m times n, this is the same thing as a to the power of m to the power of n. So 2 to the power of 3x I can rewrite as 2 to the power of x to the power of 3. So I have this plus 2 to the power of x is equal to 10. Now I'm going to let 2 to the power of x equal to the variable y. So I have y to the power of 3 plus y is equal to 10. Now if I subtract 10 on both sides, these two cancel out, and I get y to the power of 3 plus y minus 10 is equal to 0. Now I can rewrite y as 5y minus 4y. So I have this minus 10 is equal to 0. And now I'm going to switch these places and switch the order, So now I have y to the power of 3 minus 4y plus 5y minus 10 is equal to 0. Now from here, from y to the power of 3 minus 4y, I'm going to factor out y. So I get y times y squared minus 4 plus from 5y minus 10, I'm going to factor out 5. So I'll get 5 times y minus 2 is equal to 0. Now y squared minus 4, that's the same thing as y plus 2 times y minus 2. Now I have this plus 5 times y minus 2 is equal to 0. And now if I factor out y minus 2 from this, I get y minus 2 times y plus 2 plus 5. This is equal to 0. Now this is the same thing as y minus 2 times y squared plus 2y plus 5 is equal to 0. So now this is going to give me two equations. I get y minus 2 is equal to 0, and y squared plus 2y plus 5 is equal to 0. So for y minus 2 equals 0, y is equal to 2, obviously. And for y squared plus 2y plus 5 equals 0, we are going to use the quadratic formula. And I'm actually not going to waste your guys' time by plugging everything in and solving it. But if you do end up doing it, you get that there is no solution because it's going to be the square root of a negative number. So y equals 2 is my only solution for y. Now remember how we set 2 to the power of x equal to y. So now I have 2 to the power of x is equal to 2, and 2 to the power of what is equal to itself? 1. So my solution is x equals 1. Alright, so in this problem, I have x minus 4 to the power 4 is equal to x to the power 4. To solve this, I'm going to start by subtracting x to the power 4 on both sides. So then these two cancel out. Now I have x minus 4 to the power 4 minus x to the power 4 is equal to 0. Now I'm going to rewrite this as x minus 4 squared to the power of 2 minus x squared to the power of 2 is equal to 0. And if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, a is x minus 4 squared, and b is x squared. So I have x minus 4 squared plus x squared times x minus 4 squared minus x squared is equal to 0. So now this gives, now if I simplify this, I get x squared minus 8x plus 16 plus x squared times x squared minus 8x plus 16 minus x squared is equal to 0. So in my right hand side, x squared and x squared, those two add up, so I get 2x squared minus 8x plus 16 times, for my right hand side, these two cancel out, so I get negative 8x plus 16 is equal to 0. So now this gives me two equations. I have 2x squared minus 8x plus 16 is equal to 0, and negative 8x plus 16 is equal to 0. So for 2x squared minus 8x plus 16 equals 0, I'm going to first start by dividing all my terms by 2. So now I have x squared minus 4x plus 8 is equal to 0. And now to solve this, I'm going to plug this in the quadratic formula, negative b, so negative of negative 4 plus or minus the square root of b squared negative 4 squared, which is 16, minus 4 times a, which is 1, times c, which is 8, all over 2a. And this is equal to positive 4 plus or minus the square root of 16 minus 32 all over 2, which is equal to 4 plus or minus the square root of negative 16 over 2. And the square root of negative 16, that's the same thing as the square root of 16 times the square root of negative 1. And the square root of negative 1, that's equal to the imaginary number I. So I have 4 plus or minus, the square root of 16 is 4i over 2, which is equal to 2 plus or minus 2i. And for negative 8x plus 16, I get negative 8x is equal to negative 16, meaning x is equal to 2. So these are my three solutions to this problem.